Hi, everyone. Happy New Year. Thank you so much for joining us today. Welcome to the MLOps Live webinar series, the place where we discuss how to bring data science to production and unlock real business value from AI. We are thrilled you can join us today for what will be a fantastic session. I'm Edith. I'm the head of community and open source marketing at Aguazio, an AI startup that was acquired by McKinsey back in 2023. Today's topic is all about agentic AI frameworks, building foundation models, and driving business impact. It is my pleasure to introduce Saurabh Rahimi as the first speaker. Saurabh is an associate partner at McKinsey & Company. He leads the AI practice at QuantumBlack, McKinsey's AI arm, focusing on workforce management and Gen AI. Saurabh will walk us through the agentic AI landscape, share different agent-based solutions, and provide actionable insights on creating impactful agentic systems. He'll also discuss key success factors you can leverage for your own initiatives. Next, we're excited to hear from Nick Scanoni, Senior Machine Learning Engineer and Demo Expert at Aguazio. Nick will delve into the DNA of AI agents, showcase use case examples, and give us a live demo of an AI agent for predictive customer churn, complete with a code walkthrough. Finally, we'll wrap up with a live Q&A. A few things I want to mention before we begin. This session is going to be recorded and a link will be shared afterwards. So don't worry if we miss anything, we've got you covered. We'll be taking your questions throughout the session, which is always one of the highlights of these webinars. So please drop your questions in the Q&A tab at the bottom of your screen and we'll try to address as many as possible. We've added 2 new polls during today's session, so your input is valuable in shaping future webinars. We really encourage you to participate. We'll also share the poll results live. Lastly, we invite you to join our MLOps Live community to keep the conversation going after the session. We'll share the link in the chat for easy access. And now, without further ado, let's hand it over to Saurabh to get us started.
Hello, everyone. It's great to be here. And thanks, Edith, for the great introduction. Let's dive in. Okay, so as we discussed, today we're going to talk a little bit about agents, which is one of the most kind of like heard words right now in the AI community. And it's basically kind of becoming the priority of many companies. As it explained, I'm basically today serving a lot of clients, mostly Fortune 500, and I'm close to these AI conversations happening at multiple levels. And I wanted to share, before we dive into the concept of agents, maybe at a high level, what's happening right now, because it's a lot of moving pieces and all of these are connected. So we cannot talk about agents in isolation without talking about other aspects. What you see here are basically the result of our R&D research within QuantumBlack. After reading hundreds of papers, archive papers, and summarizing what are the latest trends in AI for late 2024 and early 2025. So hopefully some of these are going to be relatively new. But I'm going to pass through some of the highlights here and talk about a few things. Look, perhaps first and foremost of any AI revolution is hardware. We see that, as you know, a lot of these AI models were available before, but the major problem were training these models. And clearly GPU machines have made a lot of progress for us. But what we see today is the emergence of many types of chips right now. For example, one of the hottest one is the neuromorphic chips that can completely replicate humans' brain and is effectively many folds more efficient than current GPUs. There are other types like TPUs, etc. And these are the number of chips that are being introduced and are new are really significant. There are at least 5-10 new types that either are in the pipes or are already being introduced. which is going to help us train smarter models and perhaps bigger models, if at all it's a criteria. Um, so overall, I think we're at the bottom of an S-curve. We haven't seen anything yet. I expect in the next 3-4 years, we see way more innovations coming into the market with lots of um, you know, powerful capabilities that we consider as limitations in the current AI landscape. The second big wave of movements, or kind of like feels like a space race or AI race, is about foundation models. The latest one is R1 DeepSeek, which you've heard lately is changing the landscape and kind of like uplifting the profile of open source models almost with zero gap, almost with O1 models or commercial models um, in general, which is going to change a lot of things. It's going to make foundation models cheaper and more available to a larger group of people. There have been uh, massive advancements and adaptation in small language models. They are very good for specialized cases. They're going to directly affect how we think about agents. Um, and additionally, like the process of fine tuning and training has become much easier. Most of these LLM models, foundation models, are offering, APIs for fine tuning that is making things much easier. And perhaps one of the biggest pain points in foundation models were the evaluation metrics that were absent. We now see more and more ways of evaluating the outputs of LLMs. For example, one of the most interesting ones were the one released by Anthropic, where you can actually understand what part of the neural network architecture is being activated for every single word or token that is being outputted by the model, which helps us to actually prevent the model from providing certain answers and provide full control guardrails around how these models behave. The third thing, which I think is perhaps the most important one, is the agents, and it's going to be the topic of today's conversation. Um, and I don't see it as a technology that is being available. I see it as a paradigm shift in terms of how we think about solving problems. As you know, many of you know, agents have been around for a long time. They've been used as a core, methodology in lots of simulation models, optimization models, reinforcement learning, etc. But what happened lately was that agents became to the forefront as a new way of modeling. Um, we're using agents for the things that we didn't used to use. Um, and the combination of the old agent structures with the foundation models, which operates as the central brain and reasoning, component, has become something very powerful that is almost changing how the businesses process um, anything today. And it's the highest priority in every CEO's um, basically agenda to actually think through how to bring agents into their business processes. Clearly, there are changes in applications because agents, I mean, in a future vision, is supposed to be a one-stop shop where you don't have to deal with 50 applications on your cell phones or your laptop, and you communicate with a single agent, through verbal or other ways, um, which clearly is going to impact how we think about applications and user interface. And of course, the emergence of these models are changing how we think about talent. Like statistics is becoming less relevant for day-to-day tasks of data scientists. And I'm coming from statistics background myself. And software engineering is becoming more and more important in kind of like designing solutions for different companies. In any case, I'm just going to focus mostly on the agents part today. And hopefully by the end of this session, you understand what an agent is. And many of you already know, but at least it opens up a conversation to actually have a fruitful, back and forth and make it useful for everybody. You're going to understand what agents are and how we, at least as McKinsey, have been applying agents to our clients' cases, and what are some of the considerations and what we see in future. But let's make it a interactive conversation. We'll open it up towards the end for questions. Okay, let's go to the next slide. I believe I have it myself. 1 second. There. Okay. So look, what changed? What is an agent? At a heart of it, agents are, you should look at agents as like independent intelligence, or kind of like humans, mini humans or robotics humans that are supposed to finish a task by using tools autonomously, or understanding the requests and deciphering the requests and reason through it, leveraging memory, and communicating through certain channels. If you think about those things that I mentioned, um, it's kind of like you have a problem to solve. Instead of designing a machine learning model that does one thing, let's say forecasting, you kind of design a human to understand the problem, to actually take the right steps to solve it, break it down, use certain tools, and achieve the final goal. It's beyond like a intervention in just a part of the workflow, but rather taking the entire workflow and thinking about how to solve it, like a human does, and trying to take action. Um, this is kind of like becoming a paradigm shift in how we solve problems, right? We see more and more applications of agents in cases that we never thought that it would be the case. Now we actually see agents that do numerical processes using like foundation models that do time series forecasting and write SQL queries, pull data from database, like combine different tools like Google Calendar, Google Maps, etc., in order to finish a task. And as you can imagine, the extent of automation or insight that these things can bring is going to be much broader than a single machine learning model that is specialized to do one thing only. So that's the direction that we're going. And the real power is leveraging multi-agents as opposed to single agents. Let's think about the evolution of how Gen AI became a thing in our day-to-day business. I think at some point everybody got excited about OpenAI release. We all got to actually test OpenAI and with our prompts and everything. Then we moved on to designing RAG systems. Perhaps the first use case in every company was building a RAG system for central knowledge management. Um, Again, that was not full-on agent yet. Then we started thinking about single agents that are basically it's one brain that does everything, perhaps finishes an entire end-to-end workflow. And while we were using single agents, we realized that, okay, that it cannot be single agent to finish the entire workflow, because these agents work best if they are specialized in something. So if we basically design a specialized agent that one of them is good at, let's say, software engineering, another one is good at understanding problems and criticizing the output code, and combine these as an ensemble, you end up having a better result. And now we are moving to much bigger systems than multi-agents, like agents mesh or agent networks that operate at a larger scale. So that's where the actual power is. And if you think about the components of agent, typically, I mean, this is not set in stone, and everything is basically are flexible. And by the way, what we see is that most of companies, big companies, are trying to build their own kind of like agentic architecture that they can take to their business units. Um, Usually not off the shelf anymore. Sometimes they use open source models like LangGraph, etc. Sometimes they build everything from scratch. Um, and what we've realized is that off-the-shelf solutions that provides one solution to every problem may not be the best answer, because every company have their own dynamics of tools. They have their own kind of like user preferences. They have their own reasoning chains. So it's difficult to come up with one solution for everybody, but it is very feasible to come up with a solution that works for a company or a subset of a company very well. And so if we think about how we deliver, at least as consultants, we create like these agent frameworks, and it's comprised of multiple components that come together in order to fulfill the whole functionality. We start from data ingestion. Um, Basically, one of the challenges is that we see a lot of data that are all of a sudden becoming useful, and they used to sit in some folder in some database that nobody cared about. So we actually have to centralize all of these databases and ingest them and basically filter them properly. Um, and then comes to the actual agents, which is you should think about it as a brain, uh, as a human. Uh, the brain element has multiple components, like a human brain. Like it has memory, long-term, short-term memory, so that you can personalize it and track the problems, like a human does. It has reasoning component. It ranges from super deterministic things that is a flat like a state machine. There's an if and else logic, all the way to super, creative and you know, um, free and flexible reasoning methods like LLM based, or somewhere in between like goal oriented action programming. There are lots of different ranges of reasonings that becoming helpful for different cases. So that's another component of the brain, working closely with the memory. And then there are, these sets of tools that you make available to this brain to use depending on what the problem is. There are external APIs, like I mentioned, Google Maps, Google Cloud, etc. Sorry, Google Calendar, etc. There are internal stuff like the tools that you use every day internally. There are now models becoming available that are good at browsing, the internet. um, all of these are becoming legs and arms of this agent that we attach to this brain, so that it's a fully functional human, and it decides at what point it should use what organ in order to address a certain problem. It's heavily powerful, right? If you design this human, you can solve almost any problem that you have in your organization. um, and that's why everybody's attacking at this problem now, to see how could we improve this human to be A, as flexible as possible, B, put guardrails around it so that it doesn't generate stupid stuff, and C, it's capable of using the right set of tools in the right sequence, and create reasoning chains that could address real problems independently. So that's where we see the direction of most of research in archive is going. Actually, it's all targeted around this notion. Um, I'm gonna be very quick, but um, look, there are essentially a multi-agent framework that we put in production, is comprised of that brain that I mentioned, um, and we've configured that brain to different problems, um, by changing the reasoning and the state machine aspect to follow certain instructions, make sure it doesn't cross certain red lines that we define, and also uses the relevant reasoning that is good for that particular problem. We generate multiple agents for different tasks, and we ensemble these in a right sequence. And then we find a kind of like a powerful tool that not only is connected with their legacies, with the client's legacy systems, but also uses the collective knowledge of the organization that is kind of like being embedded in these agents, to fulfill the task with minimal error and maximize efficiency. And it works perfectly well. And I'm just going to quickly walk you through one example, and I recognize I don't have that much time. So I'm just going to quickly go through one of these client examples. So, RCM business, revenue cycle management, is a highly, regulated business. This is the kind of the business that, for example, if you're denied of service for an insurance company, from an insurance company, assuming you're, let's say, for example, you're a patient, and you need to write a denial letter. And writing that denial letter is very difficult. It actually requires medical knowledge in most of the cases. It requires writing a legal argument that complies with the regulations and laws. And it's not every man's business to do that. So there are these companies, revenue cycle management, that do that. So you can request a denial, and then they will write it for you. We thought, what if we actually create an agent that does that and automate this? It sounded a little bit wild at that point because it's a while ago. Given the regulated nature of this industry, given all the risks that are associated with like patient information, all the private data. So we tried to actually use agentic processes in this case. The way this whole thing worked was um, look into the previous denial letters and learn how to make an argument. So we extracted the reasoning chain from those previous letters, and we understood how to actually address every single case, right? And then we applied it in a forward-looking case so that you have an agent, you have now a reasoning chain that the agent can follow. And then you can now bring in different pieces of data to follow that reasoning chain and put together an end-to-end letter. And we actually ended up testing it against, actual agents. We actually did the same thing when it came to the contact centers. So you come to these RCM businesses, you have a question about, your account balance, and you want to actually address an agent to a AI agent to address it. So we did this also connecting with their 559 basically telephony system. And now a lot of the calls are being addressed by this AI agent. They take the call up front and they automate 30% of the conversation, which is, for example, authentication, using different APIs, intent recognition, and answering account balance questions, which has actually helped them with a lot of like improving customer experience performance, by reducing, the time that you spend on the line, average speed of answer, etc. So the first step that we did it, we took the last 6 months of, transcripts, and basically use our scripts to break down every call into underlying activities. And we decided, okay, what portion of the call is, for example, explaining the balance, what portion of the call is identifying the customer, etc. And we realized, okay, what's the impact if we were to build this? And then we even went one level lower to see how does an agent today identifies a customer. So you first ask the full name, then ask the social security, whatever the steps are. We extracted it through our scripts and our generative AI-based scripts. Once we had that kind of process, we started to actually basically build our agent, configure our agent that I showed, and then we put that in production. And this is one of the cases that we got a chance to test. So we got 100 users to actually go through the human agents, and 100 other users to actually go through this bot. And we distributed this survey to see, okay, how do you feel? Did we adhere to the processes based on the agent's basically knowledge? Did we retrieve the right information for the right question? Did you provide the right next steps? Was it comprehensive, relevant? Did we hallucinate or not? We started to score these, and we scored very high across the board. What we observed was that the customer experience, um, unlike the general belief, was that actually pretty high for these AI bots. We went to this assuming that these bots are not empathetic, but we find out they actually are. Because if you think about what constitutes empathy on a call, it would be like the type of like your tone, how you actually adjust your tone, what sort of words you use. Are you willing to listen more? Um, and these AI agents are capable of doing all of that. So why not? All the customers enjoyed having the conversation with them. Another insight was that we reduced the time to resolve an issue from 8 minutes to 5 minutes because these AI agents provide answers in a comprehensive way, and you don't need a lot of back and forth in order to get an answer to a question. They get the knowledge faster, and it's less likely for a customer to ask follow-up questions. Um, and therefore, the time to the resolution is much faster. The only part that we identified that is better in humans compared to AI bots was in cases where you don't finish the call and you have to hand it over to a human, a lot of the customers don't enjoy that transition. They prefer everything to be finished in one stop. Either a human handle it entirely or a bot handle it entirely. And that's the only thing that we found that can be improved in our future iterations. Um, I think that is my section. I'd like to actually have perhaps Ivy take it over. I try to stay within 25 minutes. We'll have time for the questions in the end, but I invite you to go with Ivy's poll and then Nick's presentation.
Thank you so much, Saurabh. That was insightful and very relatable. It was fantastic. Thank you. Like you mentioned, we're going to take a quick break and we're going to jump into this new poll question that we have here. If you don't mind taking a moment and letting us know what frameworks you're using for building your AI agents. It's multiple choice question. You can check off all that apply to you.
Hey everyone, my name is Nick, Senior Machine Learning Engineer with Guazio, McKinsey, and QuantumBlack. And very excited to be here today to talk to you about Agentic AI. Let me know if you guys are able to see this here. So I actually wanted to start off by briefly talking about a few articles that have come out recently on agents that I think are worth reading. The first is by Anthropic called Building Effective Agents, where they go into a lot of detail on specific design patterns and things that they have come up with and their customers have come up with in their own experience in implementing these agents. The second is called Agents by Chip Quinn. It's an excerpt from her new book, AI Engineering. I read her first book, which was excellent, and I imagine the second one is going to be really, really good as well. She goes into details on different types of tools, planning and how to decouple planning and execution, and different ways that agents can fail, both in terms of tools, planning, and other ways, and how to implement validations and evaluations throughout. And then the third article is called The DNA of AI Agents by Cedric Chi, and it's actually a comparison of the first two articles. And the main idea of this one is basically that even though these are two different articles from two different sources using two different sets of terminology, a lot of the core underlying concepts are the same. So we can start to parse out some of the emerging best practices for building out agents by looking at different sources and starting to synthesize them together. So all three of these are really great articles that I recommend reading, and we'll be using a few of the concepts in them today. First of which is this concept from Building Effective Agents on the differentiation between an agentic workflow versus what they call an autonomous agent. So this is a quote from the Anthropic article that they categorize both of these as agentic systems, but draw an architectural distinction between what they call workflows and agents, where workflows are systems where LLMs and tools are orchestrated through predefined code paths, and agents are a little bit more autonomous, where the LLMs dynamically direct their own processes and tool usage with a little bit more autonomy over how they accomplish a particular task. When I set out to build the demo, I originally envisioned building an autonomous agent, but for a number of reasons that I'll talk about after the demo, I ended up landing on a workflow instead. And I actually think it fits this use case a little bit better. And I'll talk about some of those reasons a little bit later. The last thing I wanted to mention with respect to these articles is just some of the core ideas from the last one, which is that both of these sources agree on decomposing complex tasks into smaller, more manageable units, utilizing specialized agents or components for different parts of the process, the importance of workflows, whether predefined or dynamically generated. We just kind of talked about those two different flavors, and the important role of tools, evaluation, iteration, and all that in order to improve performance in these types of systems. Another really strong emphasis for both of these articles was on practicality, on starting as simple as possible and only adding complexity as you need it, even if that means not building an agent-based system. So I think it's important to keep in the back of our minds to build the systems that we need, not the ones that we want to build. All right, so getting on to what we're building today, it is a use case on predictive customer retention. Basically, what we're going to be doing is predicting if a customer has a high propensity to churn, and then generating a promotional email using a few different data sources and some tricks that I think is pretty interesting. Business considerations, right? We're reducing churn and increasing revenue by preventing customer loss, improving customer satisfaction by addressing issues before they become problems, and increasing overall efficiency by targeting our resources towards the subset of customers that actually need it, as opposed to treating everyone the same. And then in terms of how you can expand this beyond what the demo is more of like a manual ad hoc flow where we press a button and it will generate. But you can take the same concepts and expand it to like a batch flow for mass generation of a larger email campaign or churn detection, or you can even package this whole thing up and make this available as a tool to an autonomous agent or a chatbot or a customer support agent, just to give them another tool in the arsenal. And then, of course, as you start to connect more data sources and more tools, you can get more interesting results. So in terms of the workflow patterns that we'll be using in this particular demo, one is called prompt chaining. Pretty straightforward, where you make multiple LLM calls and pass outputs from previous steps into future steps. The idea being to trade off latency for higher accuracy by making each LLM call an easier task. Then the second one is an evaluator optimizer loop. And this is where you have one component that generates content, another one that evaluates content, and you kind of go in a circle of providing feedback and refining until the evaluation criteria is met, and then you can continue on with your workflow. So we'll be using both of these in our demo today. So this is what we'll be building. This is the architecture diagram. So a number of things here on the screen, but I'd first like to call your attention to the middle section, which is what I'm calling a customer insight report. Very fancy way of saying a Python dictionary that represents customer. So this includes information about the customer that will eventually be fed into our email generation flow. It includes information like the account age, spending patterns, the number of support calls, so on and so forth, but also some more interesting pieces of data from various sources, including support call transcriptions. And this could be any sort of correspondence, Slack message, email, support calls, what have you. We're feeding these into two different models. One is a summarization model. We're using GPT-4o Mini, so we can get some of the topics and concerns that this customer's had in the past, as well as a sentiment analysis model. This one is an off-the-shelf Hugging Face model to get historical sentiment. And then we're also going through a whole training and serving pipeline using all the MLOps best practices we've come to know and love, including pipeline orchestration, experiment tracking, data and model validation, hyperparameter tuning, model serving, so on and so forth, in order to give us a random forest classifier model that is predicting churn. So all of this goes into this report, which then goes into our email generation flow, where I'm making somewhat of an arbitrary routing choice of whether or not to take action, save some money. When churn is very likely, actually just escalate it up to a human for manual intervention. But for those that fall somewhere in the middle, this is where our agentic workflow comes into play. So we're going to do a number of things like retrieve guidelines from a vector store, generate emails, review and revise in our evaluator optimizer loop, and then go into a final review where we categorize it as send automatically, review and then send, or fail, we're going to escalate this up to a human. So this is what we're going to be building today. I'm going to go ahead and stop sharing for a moment, and we'll hop into the demo and take a look at the demo as well as the underlying code to see how it works. All right. And we should be seeing a screen here. So this is a very simple front-end Gradio demo for what we're building here. I'll zoom in here. Here on the Insight report, we can see information about our customer, Peggy. She's been with the company for a little over 6 years. We have information on her usage and number of customer service calls. And then we get into some information on that came from other models. So for example, this is from our sentiment analysis model. This is from our churn model. This summary here is from our summarization model. We can see that she's concerned about the escalating cost of voice services. And then we used a rule-based engine to get the promotion that she's available for. So we fed all of this information into our agentic workflow. And what we get out of it is a generated email. So we can see here, hey, Peggy, thanks for being a valued customer for the past 6 years and 7 months, blah, 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 blah. We're thrilled to offer you a special anniversary offer. We understand your concerns about the rising cost of services, blah, 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 blah. Warm regards, IGZ Telecom. So a pretty standard promotional email, but it does have some elements of hyper-personalization, including how long she's been with the company, personalized offer, as well as directly addressing some of the concerns that she's had in the past. Then at the end, we are actually going through a few other checks. One is simulating feedback from Peggy. So how would Peggy respond to this email based on what we know about her? So it's effective in addressing her loyalty, but maybe not as effective as addressing the cost of the voice, escalating voice services. And then we did a compliance check as well, and we can see that it does in fact meet our compliance guidelines. So for these reasons, we're going to mark it as review. The reason being that it fits our compliance guidelines, but doesn't quite address everything that Peggy is looking for. So we're going to have a human review this one before we send it out, give them this email as a good starting point that they can use. So this is what we're building. I want to note that everything here is actually open source. So there is a Git repo here. So everything is available here, open source, that you can take a look at. This repo will be linked somewhere. Where the work is comprised of 3 different notebooks. One is the churn model, the second is the report, and then the third is the agentic workflow. So we're going to walk through each of these to see how it was built. So I'm going to hop into a Jupyter notebook and go through these. I'm going to kind of skim over the churn model just because it's not really the point of today. It's a webinar on agents, not really about MLOps and building out training pipelines. But long story short, I will show you what the training pipeline looks like in the UI here. So I'll pull this guy up. This is a combination of pipeline orchestration and experiment tracking view using a tool called MLRun. It's an open source tool for orchestration, tracking, model serving, and all sorts of other things that are quite interesting. But for what we're interested in today, it is a pipeline that gets data, runs our Hugging Face model to get the sentiment for each of our records. There's 3 different steps for data and model validation, feature engineering, and then training. The training actually receives a bunch of hyperparameters. We can see the best model and the evaluation metrics for this model, as well as under results here, different permutations of the hyperparameters and the best model. But what we really care about is deploying it to an endpoint, which is this guy here at the end, which I will hop back over to our notebook and show that in action. So at the very end, I'm grabbing a few records from our test set. So right here is just a list of lists of 5 different records that I want to score. And I'm going to pass this into our model. And we get a response back pretty quickly. And here are 5 different churn scores for 5 different customers. So we're going to be using these churn scores in the next notebook, which is where we generate our report. So I'm going to go here now. And there's a number of different things happening in this notebook. For example, I'm pulling data from the test set, doing a little bit of data massaging to get some categories like low, medium, high for the usage and things like that. Just a side note, I am doing all of this in memory with the Pandas data frame. In a real production system, you would probably use a database, key value store, feature store, something a little bit more persistent than a notebook, but for demo, this is okay. We're going to initialize a very simple summarization chain using GPT-4o Mini, and then combine all of this together into a Python function called get customer insight report, where we're doing things like formatting for a little bit more human readable format, inferencing our churn model, using our summarization for the support ticket, and then calling a rule-based, using a rule-based engine to get the available promotions. Again, in a real system, this would probably be a database call. So combining all this together, we get something that looks like this. We make a call, and we get a response back. So a lot of this came from our training pipeline and the feature engineering that happened there, including the sentiment label. But we just got our churn likelihood on the fly from our model that we deployed. We got the summary from GPT-4o Mini that we just called, and we got our available promotions from the rule-based engine that we just defined. So a few more calls just for fun, and we can see the corresponding reports for these customers as well. So now we can go into the most interesting part, which is feeding this into our third and final notebook, which is for generating the email itself. So I'm actually going to go ahead and pull up this architecture diagram off to the side so we can stay kind of grounded on where we are as we go through this flow here. So the first part of this agentic workflow is retrieving guidelines from a vector store. So in order to do that, we need guidelines to retrieve. So first thing we're going to be doing is ingesting some markdown files. If I go under data here, there are 2 markdown files, one for style, one for compliance. You can imagine this would be a little bit more complex in a real system. Using a markdown header text splitter to split this up into chunks, using OpenAI embeddings to embed it, and then ingesting it into a in-memory Chroma database for the vector store. In a real system, your vector store would be hosted externally in some other location. For the demo, this is fine. So we'll ingest both style and compliance, which then brings us to building out the agentic workflow itself. So I decided to use LangGraph for this. I originally started with just LangChain by itself, and I ran into a number of issues that I'll talk about a little bit later. One of the things that I like about LangGraph is this idea of a centralized graph state, where basically what you do is you define either a Python type dictionary or a Pydantic base model that essentially is the state of your application. So for example, I'll be passing in the customer report. But something that's created along the way are the style guidelines that gets retrieved, or the generated email, or feedback about different things that are generated along the way. And all of this is stored in a centralized graph state that are used in the nodes. So all the nodes are these guys here. Each of these is made up of a node, which is basically just a Python function. So it's a Python function that will retrieve the graph state. It will do something. I'll scroll past this for now. And it returns back a Python dictionary where the keys to this dictionary are keys in our graph state. So the node receives the graph state, does something, and then updates the graph state at the very end. And that's pretty much how LangGraph works for building these types of applications. So I'm going to go through each of these nodes very briefly. They're all pretty similar in how they're built. And of course, the actual code itself is in the source code in Git. So you guys can take a look at that on your own time. But this one is responsible for retrieving style and compliance guidelines from the 2 vector stores that we just initialized. From there, we are going into the generation node, where we're feeding in the customer report as well as the 2 guidelines that we retrieved. It will generate the email and then update the graph state accordingly. And then we go into this review node, where in the front end, we saw that there was a simulated customer response and there was a compliance check that was run as well. So both of those things are being run here in this review node. And then it's updating the graph state with a few different things, including the feedback from both of those different sets of criteria, as well as a Boolean value on whether or not revision is required for each of those. From there, this brings us into this branch here, which is where our evaluator optimizer loop lives, where we can either route to this revise branch or this continue branch based on the results of this guy right here. So basically, if we have revisions left and revisions are required, go ahead and revise. Otherwise, just go ahead and continue to the final result. Last 2 nodes we'll take a look at is the revise, which is basically just feeding in everything up until this point, the email, the customer data, the feedback, and the guidelines to go ahead and regenerate, as well as update our number of revisions -1. And then the final review here is what's categorizing into these different final buckets, basically, where it's going to be categorizing into pass, review, and fail, of whether to automatically send human review before sending or fail human intervention, as well as the reasoning behind it. And that will be the final node in our graph. So then in order to combine all these together, again, we're using the LangGraph. So we're feeding our graph state object to create this builder. And then what we can do is add nodes, where each of these nodes is one of the Python functions that we just looked at. And then once we have all of our nodes, we can combine them using edges. And what we say is, start goes to retrieve, and then retrieve goes to generate, so on and so forth, all the way until the end. And then what we can do is define conditional edges. And these conditional edges can be as simple or as complex as you'd like. For our purposes, it's this guy right here, where we are either routing to revise or continue based on the output of this should revise function here. Finally, what we can do is compile it into this LangChain runnable, and then print it out, and we get something that looks pretty familiar. And then what we can do is test it out. So I have a few reports here that I pre-generated that are available for you to try out. We have Peggy, Hank, and Bobby. So we're going to go ahead and generate one for Hank this time. And the way that you would call it is this guy right here, graph.invoke. Pass this in, and we can see it start to do stuff. Nope. Call it one more time. Gotta love live demos, right? We're gonna run this from the top, just so we have the latest here. We'll let this guy go. But basically what it's gonna do under the hood is call each of those different nodes in the correct order, generate each of those things and update the graph state. And then at the very end, will give us our output. So let's just check on this guy here. All right. Well, we're going to go ahead and continue on here. But basically what this will do is do all of that and provide us with a Python dictionary that includes all of the output here, as well as actually the entirety of the graph state. So it also includes intermediary steps as well, including things like, okay, here we go. So generating, simulating, it'll go ahead and simulate the customer response as well as the compliance information, so on and so forth, and give us an output. At the end here is our front end, which is using Gradio, that is available here for you to play with and adjust as you see fit. And again, all of it is available in the open source. So I'm going to go ahead and hop back over to the slides really quick, and we're going to take a look at some of the challenges that I ran into along the way as we were creating this. Let me go ahead and share my screen again. Here we go. And so I wanted to touch on what did and did not work. I realize we're running very short on time, so I'll be very brief here. I ran into some issues around LangChain itself just being kind of difficult and having a number of abstractions inside of it and kind of making it difficult to customize, as well as state management being a little bit challenging. And the control flow as well was kind of difficult to get right. I started trying to build out an autonomous agent. It wasn't quite following instructions in terms of reviewing and revising before returning or using the correct tool to review. It just decided to review by itself. So for a number of reasons, including these, I ended up switching to the agentic workflow instead. And in terms of what did work, I thought that the combination of traditional ML and generative AI worked quite well in this use case. Basically use the traditional ML model for what it's used best for, which is, computing numbers to ground the LLM in terms of the context, and it allows you to add additional models as you see fit later on. The switch from the autonomous agent to the agentic workflow worked well here because you can ensure that it followed certain steps, kept the implementation simpler, and it also gives you an estimate for the cost and latency. Whereas if you have, an arbitrary agent calling arbitrary tools in an arbitrary order, it can be kind of difficult to tell how much it costs and how long it will take. Whereas in a more structured workflow, you get a better idea of that. And then switching from pure LangChain to LangGraph just gives you more control and better state management. So hopefully that was interesting, and hopefully there was some good information in there for you. I'm going to go ahead and turn it back over to Adit.
Thank you, Nick. That was incredible. I'm going to jump over right now to our poll. As you mentioned, we can go a little bit over. We have a bit of time, but I'm going to go ahead and launch the second poll. What are your biggest challenges when implementing Gen AI based agents? I think both Sarab and Nick talked about common challenges in the industry from projects that they've worked on, that they've experienced themselves, but we would love to hear from you. We got a lot of fantastic questions throughout the session, which we are not going to be able to go through all of them because there are a lot. And I'm gonna start off with a few. And Saurabh, Nick, feel free to turn on your cameras and jump in and choose ones that look interesting to you. But I think something that would be interesting to hear from you, Saurabh, was someone asked about what would be an intuitive way to plan the development of a multi-model agent in the sense of defining milestones? I know you touched on that, but maybe you can elaborate a little more.
Makes sense. I think it depends on the use case, right? They vary a lot, use case by use case, but typically we start with, let's say you're designing a multi-agent for automating a certain process. Let's say in a contact center, you want to create a conversational agent. You start with the historic data sets usually, and try to, as a first step, understand how humans do that job, right? For example, you could use call transcripts. You could use recorded, record the monitor in case it's not conversational and track like the mouse movements. But in any case, once you get that data, you usually use a LLM-based model in most cases in order to understand the underlying steps that a person takes in order to finish a job. So for example, looking at every single call in the past 6 months, I will identify what the agent does to authenticate a user, what an agent does to ask the intents, etc., right? Typically, that's noisy. Like every agent does it differently. So that's why a probabilistic model would be very helpful to actually understand the distribution of actions at a high level. Once you get that, you share that with SMEs to actually see if it makes sense, if there's something that needs to be improved there. And then you kind of like get to a typical workflow, which is very detailed, very granular, and it actually maps out all the human activities for every single call type or action item, which is your kind of blueprint to kind of use going forward and start designing how your agent milestones should be, right? So at that point, you have to decide for every single one of these workflows, what are the one agent or sequence of agents that I need in order to address this particular question. And you should have that in mind, that when you're designing your multi-agent, what are the limitations of an agent? What can it do well versus not? Typically, you want the agent to do one task, right? Just do one thing very good. And that's where you'd say, okay, for example, for authenticating a user, I need an agent to actually verify a person's address using Google Maps. I need another agent to make sure my tone and words that I use are in alignment with the user's sentiment. I need another agent to break down the problem to underlying requests. Sometimes a person comes up with a request and there's 5 underlying tasks in it, right? So you kind of like do it like that, workflow by workflow, agent by agent, you design it, and then you bring everything together with an orchestrator.
That makes sense. Thank you, Saurabh. A question for Nick. Once a team gets into the production, who maintains the code? Have you seen functioning processes?
Great question. As with all great questions, the answer is it depends. I would say it depends on the size of the organization and whether you have a dedicated like MLOps team or say DevOps team or IT infrastructure team that is managing that, managing on the infrastructure level. And then you may also have data scientists that are keeping track of monitoring like data drift or things like that, which would also expand to the LLM world of traces and keeping track of different things that the models are saying over time. So I'd say it's a combination of both data science oriented monitoring as well as operational monitoring, which might be covered by the same team, or in a larger organization could be handled by two separate teams.
Thanks, Nick. Regarding the evaluation of the use cases, at what point does it make sense to move from automations or co-pilots to autonomous agents? We got a few questions about autonomous agents.
Yeah, I mean, you know, the theme for this year and next year are still going to be around Copilot, because the biggest thing that people are trying to solve now in research is what's the right cadence and you know, working model for humans and machines, or AI together. It turns out that AI is clearly good at some things and humans are good at other. So instead of replacing one with another, why don't we basically create a Iron Man suit for every human, which is this whole AI capability to maximize productivity. What humans are good at is identifying gaps, and we can always identify gaps to see what machine is incapable to do and fill that gap. And we recognize, like in the world of AI, as was like many comments were brought up, there are always gaps, right? That's how these models are designed. Unless there is a case where you actually come up with a LLM model where you could actually put guardrails fully around. Until then, you would need human in the loop. With that said, agents are not necessarily limited to use LLMs, right? You could have an agent that is purely deterministic, using perhaps older LLM models or optimization models. Giving you an example, when I authenticate a user, I don't need to be a creative problem solver, right? I just need to follow certain processes. So in those cases, I feel more comfortable to do autopilot and not copilot. But for actual problem solving stuff, which is where the value of these whole AI agents or LLM-based agents are, you still need human in the loop, at least until the foreseeable future.
We're not going to be replaced just yet.
Not yet.
Okay, one quick question for Nick. I'm just going to answer one quickly. Someone asked about how do you deal with instances of different customers, different languages, dialects when calling the call center. We have a few demos that we can share with you guys and show, yes, different languages being used in various examples. But for Nick, where was the question? Oh, it's a specific question on your demo. You said a combination of traditional ML is a better choice. The question is that because of reasoning capabilities of LLMs, or is it because of explainability?
Yeah, so it's a really great question. I think that traditional ML has been used for a number of years in tried and true ways for computational tasks. And these models are really good at calculating numbers and being reproducible and deterministic in how it creates a response. These types of tools and outputs of these models can then be used by an LLM to ground it and give it some sort of ground truth. So it's not hallucinating, numbers and things like that in order for the actual generative portion of the task. So basically using the best tool for the job, I would say is what the idea is. And explainability is a big part of that. So if you need to explain why, we're using this particular output from a model, it's a lot easier to explain traditional ML models than it is to explain what an LLM is doing. So I'd say absolutely.
Thank you so much. All right, we're out of time for the Q&A, but as Bela has shared the link to our MLOps Live community, we will try to answer more of these questions offline, and feel free to connect with us, and we'll do the best to answer as many questions as possible. Now, I wanted to just take a minute, and before we wrap up, I want to invite you to explore our website, guazio.com. You'll find past webinars. I saw some people ask. We have all 34 sessions. Tomorrow we'll have this one up on our website, and we will share the recording with you. You'll find past webinar sessions along with a wealth of additional resources like blogs and case studies, best practices, and we'd love to hear your feedback as well. So do take a moment and check that out. And I can't end the session without saying a huge thank you to Saurabh and Nick for your excellent presentations. And of course, our heartfelt thank you for all of you for joining, taking the time out of your busy day, and participating in our chat. We really, really look forward to seeing you at the next session, and I hope that you all enjoyed.